Ever wondered why diamonds sparkle? Why optical fibers send information at the speed of light? Or why sometimes you see watery illusions on hot roads? Let's unlock the physics secret behind these mesmerizing sights. Total internal reflection. Total internal reflection, or TIR, is a phenomenon where a light ray, instead of passing through or escaping a surface, is completely reflected back inside a material like glass or water. It's like the ultimate mirror, but happening entirely within the material itself. But TIR doesn't happen just any time. Two golden conditions must be met. First, light must travel from a denser medium, like glass or water, to a less dense one like air. Second, the angle at which light hits the boundary, called the angle of incidence, must be larger than a special value known as the critical angle. Show ray gradually increase angle of incidence so you can see refraction transition to total internal reflection. The critical angle is the cutoff. It's the smallest angle of incidence where all the light is reflected inside and none escapes. Mathematically, it's given by Thc equals sign sin circumflex -1, n_2, n_1, where n1 is the refractive index of the denser medium, and at n2 that of the less dense medium. Full reflection begins. Every material pair has its own critical angle. Here are key examples. Water to air, 1.33 to 1.00, about 48.6 degrees. Glass to air, 1.52 to 1.00, about 41 degrees. Diamond to air, 2.42 to 1.00, about 24 degrees. For example, water to air, about 48.6 degrees. Glass to air, about 41 degrees. And for sparkling diamonds, just around 24 degrees. Where do we see TIR in action? Mirage. Hot roads seem wet as light bends and reflects in layers of hot and cool air. Sparkle of diamonds. Light reflects multiple times inside the diamond due to its low critical angle, creating incredible brilliance. Inside water, from underwater, fish see the surface as a mirror past a certain angle. Where do we see TIR in action? TIR powers modern technology and science. Optical fibers, high-speed internet and medical endoscopy. Light bounces down tiny glass fibers with zero loss. Prisms in binoculars and periscopes. Light takes a sharp turn with no energy lost. Safety reflectors, used on bicycles and road signs. Decorative lamps and rainbows. From science to art, TIR paints with light. TIR powers. Modern technology and science. Total internal reflection is at the heart of so much dazzling science, from natural wonders to cutting-edge tech. Next time you spot a sparkling diamond or video chat with a friend, remember, it all reflects back to this brilliant bit of physics. Like, subscribe, and let us know which TIR example amazed you the most. See you in the next video.